Hey everyone, I hope that you had an awesome weekend. Welcome back to math. Today, you guys, are on to lesson 24, and we are actually starting measures of center. If you need it, you guys, that's chapter 9, section 4 in your math book. Today, you guys, you're going to want to grab a loose leaf piece of paper. You're going to want a pencil, and you might want a highlighter too. Also, what I'm showing you today, you might want to screenshot when you can, because there's a lot of things to kind of copy and a lot of things to notice. So if I was you, I'd screenshot. And I'll kind of give you a heads up on the slides. I think that you should. Okay, so check it out. Today, you guys, we're going to be looking at some data. The data that we're going to be looking at is from temperatures of 10 random days in May last year. So I just went outside and I recorded the weather on 10 random days. Okay, so our main focus today, you guys, is that we are going to be looking at measures of variation. And when you hear that word variation, it means how much something varies or how spread out it is. So what measures of variation are measures that describe the distribution of a data set. And that means how scattered and spread out our data is. So we're looking at data today on an even more refined scale. We're not just looking to see, okay, what our mean, median, and mode is. We're trying to decide, is our data really smushed together? Are all our numbers really close together, or are they really spread out? And that's what measures of variation is really good for. So check it out. Below here, you are going to see these are the different temperatures for the days that I tested last year. So one day it was 65, another day it was 90, another day it was 70, and so on. Wow, I really hope May warms up like that. We'll see after our April. But one thing that you guys have done already is you actually already know how to calculate the range. So this one is just a little bit of a reminder. The range is the difference between the maximum or your largest value and your minimum or your smallest value. So if we were going to go and figure out the range of this data, I'm going to write that. Our range, what we would do is we would find our greatest value, and our greatest value, I think, is 100. So we would take 100 minus, did anybody catch what your smallest value was? If you said 65, you're absolutely correct. And 100 minus 65 is 35. Okay, and what that means is that all of our temperatures that I looked at in May, they range somewhere within 35 degrees of one another. So that pretty much sounds like Michigan. So we could have a really kind of cooler day of 65, and then it can go all the way up to 100. So that's where we've been. This is getting into the newer stuff. Today we're going to be, guys. Today we're going to be talking about something called quartiles. And what quartiles do is it divides a set of data into 4 equal parts. When I think of quartiles, I think of quarters. How many quarters are in $1? If you said 4, you're absolutely right. So there's 4 quarters in $1, and each one is usually 25 cents. Keep that number in mind. We'll use it a little bit later. So today we're going to be looking at this new term called the first quartile, and you can shorthand it to Q1, and that's the median of the lower half of our data. And we're also going to be looking at quartile 3, and that's the upper half, the median of the upper half of our data. And if you're still going, I'm not sure about this right now, don't worry. Let's take a look at some examples so you know what I'm talking about. So most importantly, friends, whenever you're dealing with median, that's the one where it's so important to line up all your values from smallest to largest. So you can't just look at your values and start crossing off and figuring out your median. You have to put them in order. So I did that right here. Let's go ahead and solve from there then. So this is my data. These are the temperatures. I put them in order. Your first step when you're dealing with quartiles is you always want to go ahead and you want to calculate the median. Now, I'm going to switch my color actually. In the past, when we were calculating your median, I told you guys, start crossing off one from the larger side and one from the smaller side because we're trying to find the middle. The only thing, you guys, is I don't like crossing them off anymore because then I can't see the number very well. So a practice that I've gotten into is I start putting a dot under them now. So I'm looking for the middle or the median. So I'm going to cross off one from the high side, one from the low side, two from the high side, two from the low side, three from the high side, three from the low side, four from the high side, four from the low side. Now what you're going to see is that leaves me with two numbers right here. I need to know what's in the middle or the median of them. Now you have two choices. You might recognize right away that what is in the middle of 80 and 82 is actually 81. If you didn't catch that, what you could do, I just want to remind you, is you could take the mean of those numbers and you could take 80 plus 82 and divide it by 2. And if you did 80 plus 82, that's 162. And 162 divided by 2 is 81. So again, that's kind of up to you if you recognize it or not. But what that means is that, I'm sorry guys. What that means is that our median is hanging out right there. Our median is actually gonna be, I'm gonna draw a little arrow, is gonna be 81. So that's our second quartile. And what that does, friends, is that cuts our data in half. You've got your, and I'm going to do that right away actually. You've got your lower half, and that hangs out over here. So your lower half of your data is underneath the median. Now, on the other hand, your upper half of your data is on the other side of the median. Now, we're not going to quite get into this yet, but I think you guys are ready for it. If you're looking at this, and I'm so sorry, you guys, I'm having terrible allergies, so I'm sorry if I'm sniffling. When you're talking about half of something, what that means is that we're talking about the lower half of the data, or the bottom 50% is hanging out in those numbers, and the upper half is the upper 50% of the data. All of the data together would be 100% of our data. But again, let me get to that a little later. I just kind of wanted to show you so your brain is already thinking. Now, from there, guys, what you're going to do is in the lower half, now what they want you to do is they want you to calculate your first quartile. And that's the median of the lower half of your data. So what we do to do that, I'm going to use another color. I'm going to switch to green. What we need to do is we need to calculate the middle of the lower half of the data. So I'm going to cross out right here 80, and then I'm going to cross out 65. Then I'm going to cross out a second one, 75, and a second one from the small side, 65. What that means is that 70 is actually my first quartile right here. Let me grab it. Okay, now the same thing is done actually on the other side. Now we're going to be looking at our upper half. And what we need to do is we need to calculate the median of the upper half of the data. And that becomes your third quartile. So again, I'm going to cross out 100 and then one of the smaller ones, 82. And then 95 and then 85. That leaves us with 90. And what 90 is our third quartile, or the, oh my gosh, I'm so silly. That should say the median of the, I can't believe I did that, the median of the upper half. If you caught me, I'm really proud of you. So that's the median of the upper half of our data. So I'm going to try and show you a neater version of this to make it a little bit more clear. And of course, please, you guys ignore that. That's the upper half. So what you're seeing right here, you guys, is all of our data. You've got your first quartile right here, which goes up to 70. That's your first quarter of data. Then you've got your second quarter of data, which goes up to quarter 2. What that means so far is that 25% of our data falls below our quartile 1. Quartile 1. And what that means is that another 25% of our data falls in our quarter 2. Are you seeing the pattern now? Then going from quarter 2 to quarter 3, another 25% of our data falls there. And finally, you guys, the last quarter of our data falls right here. 25% falls. And I should label this. This is quarter 3, and this is quarter 4. So that's kind of how our data falls, you guys. So in quartile 1, I'm going to use my highlighter. In quartile 1, 25% of our temperatures fall below 70 degrees. In quartile 2, we could say that, actually, you guys can combine this. Quartile 2, what that means is that 50%, because 25% and 25%, 50% of our temperatures fall between 81 degrees, under 81 degrees. On the other hand, if I use a different color, I could even say that 50% of our data, or 50% of the temperatures are above 81 degrees. Be helpful if those colors didn't mix. So you guys, it's all about breaking our data into pieces. Quartiles are breaking it into quarters. So quartile 1, 25%. From quartile 1 to quartile 2 is another 25%. From quartile 2 to quartile 3, another 25%. And from quartile 3 to the final end, quartile 4, is another 25% of our data. Now, there's one more term that you guys might end up hearing, and that's the interquartile range. What they want you to do for the interquartile range is they want to know the difference. They want to know the difference between your first quartile and your third quartile. The interquartile range accounts for, that's where 50% of our data falls. Because remember, that's quartile 1 to quartile 2. That was 25% as a tip. And from quartile 2 to quartile 3, that was another 25%. You won't let me write. Another 25%. So interquartile range is really important because that means that's where the middle 50% of all of our data falls. So if I'm figuring out my IQR, what I'm going to do is I'm going to take my quartile 3 number, which was 90 degrees, and I'm going to go ahead and I'm going to subtract my quartile 1 number, 70 degrees. That means that my interquartile range is 20 degrees. Now you might be going, okay, but Mrs. Huang, why is that important? Here's why. This is what it means. If we're interpreting our IQR, what that means is that the middle 50% of our data, or the middle 50% of our temperatures, didn't vary by any more than 20 degrees. So most of our temperatures in May fell somewhere between 20 degrees of one another. Now, that's basically the new stuff that we're learning. I just wanted to show you one more example. Stay tuned in for another second because I just wanted to show you what's a teeny bit different about this one. My apologies. I know it's a little bit kind of grainy when you look at this. So you guys, this data is for 12 sports cars and how fast they can go. Oh my gosh, I'm feeling very nervous. One of these cars goes 220 miles per hour and the fastest one goes 270 miles per hour. But if you went ahead and you list all this data out, the only difference this time, you guys, is that I want to remind you, when you went ahead and started crossing numbers out and found the median, that brought you in the middle of 245 and 250. So you had to do that calculation where you added them together and divided by 2. So your median was 247.5. Now, when you went to find your Q1, and I'm going to change this color. When you went to find quartile 1, you had to do kind of a similar thing. You started crossing off 220 miles per hour, 245, 230, 240. This time is different from the example I just did. You end up with 2 numbers in the middle. So what you had to do is you had to add the 2 numbers together and divide by 2 to give you a quartile 1 of 235. And finally, you guys, that last one, I'm going to get one more color. The last one, friends, is a similar idea. Now you're in the quartile 3. Okay, so what you had to do is you had to go ahead and you had to find the middle of the upper half. So you crossed off 250. I should have used my highlighter. 250 and 270. Crossed off 250 and 260. That left you with right in the middle here. Now you might be going, Mrs. Huang, I know that 255 is in the middle of 250 and 260. If you did, fantastic. If you didn't, you would go ahead and do that same algorithm. You would solve. Finally, if you wanted to know your interquartile range of this data, you would take your quartile 3, 255, subtract your quartile 1, 235. And again, that means that 50% of your data falls between 20 degrees. All right, guys, I hope that was clear for you. I'm going to put another video from Khan on there too, because I think it's just one more example that helps. It's real short. So go ahead and watch that next. Okay, I love you guys. I miss you. I wish I could see you guys. Have fun today. Bye.